Okay, welcome everyone, period 6, welcome. It says we're doing exercise 21, problem set 10, okay? Theo has won a new car on a game show. And when his shiny new car arrives on a warm day, 28 degrees Celsius or 301 Kelvin, the tires, the 0.016 cubic meter tires have an air pressure of 202,000 pascals. However, 2 weeks later, when the temperature drops to 273, 0 degrees Celsius, cold, still maybe the fall or early winter, so that's probably, you know, at least 45th latitude-ish, southern New York, right? Right? Pennsylvania, yeah, northern Pennsylvania. Where was I? However, 2 weeks later, when the temperature drops to 273 Kelvin, Theo's air pressure gauge reads only 190,000 pascals. What is the new volume? What is the new volume of the tires? Okay, right. So let's write some data down, okay? We have, what do we have? We have temperature, volume, and pressure. Is that correct? Yes? So right away it's going to be combined gas laws, yes? Yeah. No, not Gay-Lussac. It's going to be Boyle's, Charles, and Gay-Lussac. It's all in one thing, okay? And I'll show you that in a second, okay? Yes, just wanted to, you know, when you do these problems, it's very important to think ahead, okay? You hear that? Think ahead, okay? So that's called thinking, really. Don't let the problem lead you around. You lead the problem. You control it. Control your surroundings. Try to find out where the problem is going before it actually asks you a question. Do you understand that? How many people normally allow the problem to control them? Anybody? No one's raising their hand except Mickey. They're all guilty of that. Are you? Yeah, everybody's guilty. Yeah, Haley? Yeah. You're all guilty of that. Take control of the situation. Okay?
That's weird that you're...
I just gave somebody the evil eye. They did something wrong. Okay. Now, so we have combined gas laws. So P1, V1, T1. Okay? What's the pressure? The pressure is 202,000, right? Pascals. Yes? All right. What is the volume 1?
0.016 meters.
0.016 meters cubed. And what's temperature? 301 Kelvin. Okay? Yes? Remember, think. Gas laws. Okay, gas laws. I can do this. Only Kelvin in gas laws. Understood? Okay. And then what are the others?
P2 is 190,000.
So the temperature, the pressure is going to drop to 190,000. Can you see that? Can you see that? Up there? Yeah. It gives a little bit of a leeway, okay. And the temperature is 0 Celsius, which is 273 Kelvin. Okay? 273 Kelvin, and we want to find the volume. Clear?
Clear.
Is that correct?
Yep.
Okay. So, easy? Yes? Yes? Okay. So, PV over T equals PV over T. Correct?
Yeah.
Yes? 1, 1, 1, 2, 2, 2. This just means beginning conditions is 1, ending conditions is 2. Beginning, ending. Start, final. Initial, final. 1, 2, A, B, whatever you want to say. Understood? Okay, let's plug into this. Okay? Plug in. All right? Now, what I want you to do is I want you to plug in. I'm going to do this myself. Okay? I'm going to do this. I want you to do it yourself at your desk without looking at the board. Okay? Brian, you with me? Okay. Excuse me while I do this, okay? Okay, you with me? All right, before we actually calculate this, let me just show you. Somebody said, well, it was Gay-Lussac's law. Somebody else may have said Boyle's. Someone else may have said Charles's law. Well, they're all there. This is called the combined gas law. In other words, if I hold T constant, in other words, it's the same on both sides, that will drop out. So it'd be PV equals PV. Do you see that? That's Boyle's law. If T is constant. If P is constant, what law is that? If P is constant, what law is that? Charles' law. If V is constant, what law is that? Gay-Lussac. Do you get it? There are all three of them there. Three. Yes? Okay. So, cross multiply and divide. Try to keep your wits about you. It's actually very simple. It's going to be, calculate this out. You ready? Okay? Get your calculators out.
Calculator.
Calculator. Okay? 202,000 times 0.016, right? Times, cross multiplying, times 273, correct? Yes? And then divided by the rest. Divided by 301, divided by 190,000. Yes? Do you get that? Shall I do that again? 202,000 times 0.016 times 273 divided by 190,000 divided by 301, and what do you get?
0.015.
Excuse me while I look. What did you get?
0.015.
0.015. So V2, we'll put it up here. We'll put it in a different color. Cool? Okay?
Awesome.
So it'll be 0.015, right? Can we read that? Let's put this all in another color. Is 190,000 pascals. V2, T2 is what? What did we say it was? 273? Okay. And then this is going to be, the answer is going to be 0. What? Is that correct? Now notice I left the unit labels out. I say this all the time, I know, but I say it because it's important for you to start to identify unit labels correctly. Mickey? How tall are you? 150 pounds? Does that make any sense?
No.
No. How much do you weigh? About 5'9"? Is that pretty close?
About 10.
Yeah. What's the density of gold? 20 degrees Celsius?
No.
No. 19,300 kilogram per meter cubed, right?
Yeah.
What's the speed limit on Route 18? Is it, make this multiple choice, are you ready? Is it 55 miles an hour where posted? Or is it 100 pounds?
100 pounds.
You can do the math, but if you don't know the unit labels, you don't know the physics. Clear?
Clear.
So what I do is make sure that these are all standard. Standard. Everything is standard. So plug in without any unit labels. You're calculating volume. Volume is standard. Volume is meters cubed. Done. Clear?
Clear.
Clear.
Excellent. Hey, it's Friday. Be careful out there. Don't do anything I would do, okay?
What would you do?
We don't have time. See my book.
You should write a book.
Yeah, you should before you.